Here's the start of Unit 4. We're looking at radical expressions now. The objective of this particular section of notes is to simplify radical expressions and specifically square roots. We're going to just start looking at this set of notes in this video, and we'll finish up this set of notes in class. So in this particular slide, we're just kind of defining some notation. This letter N here shows us what the index or the root is. Typically in our notation, there will not be anything written there because we're going to be using the square root. And when we use the square root, there's no index written. Other times you might see a 3 written there to indicate a cube root, or a 4 written there to indicate a 4th root. But again, in our case, when we're looking at square roots, you will not see a number actually written there. The radical sign, which is this symbol here, is written as such. And then the portion that's underneath the radical sign is referred to as the radicand. Now, previously, we looked at the properties of integer exponents. Now we're going to extend those properties and talk about a notation that's going to reverse that process. So in general, we can state that if a to the n equals x, then a is considered an nth root of x. So to be a little more specific, if a squared equals x, then we can say a is the square root of x. So for example, we could say if 5 squared equals 25, if 5 squared equals 25, then 5 is the square root of 25. Or we could say if 2 squared equals 4, then 2 is the square root of 4, so on and so on. Okay. So it might be helpful for you to go back and recall the square roots of the first 16 positive numbers. Okay. It's good especially to know up until at least the first 12, but knowing up until at least 15 and 16 is really a good idea. So it would be a good idea to really take some time and look at this chart and try to memorize it. You probably know the first at least 10, hopefully, by memory already, but try to spend some time with some of those larger numbers if you don't know them already. Now, with that in mind, you can go ahead and complete the second chart of the first 16 perfect square roots. Okay, so the square root of 1 would just be 1, because 1 squared is 1. The square root of 4 would be 2, because 2 squared is 4. The square root of 9 would be 3, because 3 squared is 9. Okay, the square root of 16, the square root of 16 would be 4, because 4 squared is 16. The square root of 25 would be 5. The square root of 36 would be 6. The square root of 49 would be 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. Okay? Pause this video, see if you can go through and complete the rest of this chart, and then check back and see what you got. Hopefully you didn't have too difficult of a time filling in the rest of this chart. Again, it's really a good idea to know those first 16 perfect squares and the square roots. It would be a really good idea if you're not comfortable with those already to even make a set of flashcards so that you can quiz yourself on those perfect squares. Okay. So let's try a few. Square root of 169, 13. Square root of 64 is 8. Negative square root of 36 would be a negative 6. Now be careful on this last one. The square root of negative 100, some people want to say that the answer is 10 or negative 10, but in our case the answer would actually be no real number. Okay? There's no number that when we multiply it by itself or when we square it would give us an answer of negative 100. If we multiply 10 times 10, it would give us a positive 100. Or if we multiply negative 10 times negative 10, it would also give us a positive 100. So there's no number that when we multiply it by itself would give us a negative 100. So there's actually no real solution to this particular problem. So if you ever come into a situation where you're asked to find a solution for a negative number underneath a square root, so when your radicand is negative, the answer will always be no real number or no real solution. Okay. And those are all the slides that I asked you to look at before class on Friday. So thank you for taking the time to do that, and I will see you soon.